This is problem 2 on the Manipulating Vectors with Trigonometry worksheet. We have a 100-pound stoplight suspended from two cables. We're going to call them the cable on the right. The tension in that is T sub r. The tension in the cable on the left is T sub L. What is the tension in each cable? Well, the gravitational force is pulling downward on the stoplight with the force of 100 pounds. The stoplight's just hanging there, which means there's a net force of 100 pounds upward on the stoplight, and that's supplied by both tensions. The upward force must add to 100 pounds. So let's put a force diagram on there, put some vectors, and let's try to draw it roughly to scale. 100 pounds straight down, gravity on the stoplight. There's the right tension, there's the left tension. We can imagine that the right's going to be bigger. The right's doing most of the holding up of the stoplight. So let's insert the vertical and horizontal components of the tensions because we want to really understand fundamentally what's going on, not follow rules. There's T left upward. Here's T right upward. Here's T left to the left. Here's T right to the right. With a good diagram, we can see what's going on, and that's the goal. We want to really understand, not follow rules. The sum of the upward components must be 100 pounds. TLY plus TRY must be 100 if they're holding up the stoplight. In the horizontal direction, they must balance because it's just hanging there. So T right X has to be T left X. These two vectors have to be the same length. Forces have to be the same. These two vectors have to add to 100 pounds. So now we understand what's going on. We can use some trig to get an expression for the components. So in the vertical direction, the y direction, TR sine 70, that's the opposite side, plus TL sine 30 is 100 pounds. These two add up to 100 pounds. They're holding up the stoplight. In the x direction, they balance. So T right cosine 70. T right is this vector. Cosine 70 is the adjacent side to the 70 degrees. Balances TL cosine 30. Two equations, two unknowns. We have to do some algebra. I'm going to start with the x direction to get a relationship between the two tensions. So if we divide both sides by cosine 70, we get this relationship, and we can plug in for the angles with our calculator. So T right is about 2.5 times T left. Not surprising. T right is doing most of the work. So now we can substitute that expression, T right equals 2.53 T left, into the y direction equation. There's the y direction equation. And we're going to substitute in for T right there, 2.53 T left. Now we can calculate what these sine of these angles are, get some numbers for that, add up those two, and we get 2.88 TL is 100 pounds. We solve for TL by dividing by 2.88, and we get about 34.7 pounds. We know TR is 2.53 times that. So we calculate that, 87.9. Let's check. The vertical components should add to 100 pounds. So TL sine 30 plus TR sine 70 should be 100. There's TR sine 70, TL sine 30. We calculate them, and we get 82.6 and 17.4, and that's 100 pounds. Check. Good job.